When installing two 200 amps electrical panels fed from a single 400 amps meter base in a residential setting, the grounding requirements are often a point of consideration. According to standard electrical practices and the National Electrical Code, a single grounding electrode system is sufficient for grounding both panels. This means you do not need separate ground rods for each 200 amps panel. Instead, you can use one ground rod and connect both panels to it. The connection to the ground rod is achieved by using a grounding electrode conductor, commonly referred to as a ground wire. This wire must be sized appropriately based on the size of the service entrance conductors. Refer to NEC Table 250.66 to determine the minimum size of the grounding electrode conductor. This table provides guidance based on the size of your service entrance conductors, which in this case are feeding the 400 amps meter base. The grounding electrode conductor connects to the ground bar within each of the 200 amps panels. It is crucial that the ground bar is properly bonded to the metal enclosure of the panel. This bonding ensures that any fault current will have a low impedance path back to the source, allowing the overcurrent protective devices, such as circuit breakers, to trip and clear the fault. The ground rod itself should be at least 8 feet in length and made of a material suitable for grounding, such as copper or copper-clad steel. It should be driven into the ground until at least 8 feet of its length is in contact with the soil. The location of the ground rod should be carefully chosen to ensure it is in an area where the soil is likely to remain moist, as this improves its effectiveness. The connection between the grounding electrode conductor and the ground rod should be made using a listed grounding clamp or connector. This connection must be mechanically secure and corrosion resistant to ensure a reliable and long-lasting ground. In addition to the ground rod, it is also important to bond the metal water pipe to the grounding system. This is typically done by connecting a bonding jumper from the ground bar in one of the electrical panels to the metal water pipe within 5 feet of its entrance to the building. The size of this bonding jumper is also determined by NEC Table 250.66 based on the size of the service entrance conductors. Bonding the water pipe helps to ensure that it is at the same electrical potential as the grounding system, reducing the risk of electric shock. It is also important to bond any other metallic systems that may be present in the building, such as gas pipes or metal ductwork. These systems should be bonded to the grounding system in a similar manner to the water pipe, using bonding jumpers of appropriate size. The purpose of bonding these systems is to minimize the potential difference between them and the grounding system, further reducing the risk of electric shock. When installing the grounding system, it is important to follow all applicable electrical codes and regulations. These codes are designed to ensure the safety of people and property, and they should be strictly adhered to. It is also important to use qualified and experienced electricians to perform the work. Electrical work can be dangerous, and it should only be performed by those who are properly trained and equipped. Firstly, ensure the ground rod is listed for grounding purposes. Secondly, drive the ground rod at least 8 feet into the earth. Thirdly, use a listed clamp to connect the grounding electrode conductor to the ground rod. Fourthly, protect the grounding electrode conductor from physical damage. Fifthly, bond the metal water pipe within 5 feet of its entrance to the building. Sixthly, bond any other metallic systems that may be present in the building. Seventhly, use appropriate sized grounding electrode conductors and bonding jumpers, referring to NEC Table 250.66. Eighthly, ensure all connections are mechanically secure and corrosion resistant. Ninthly, inspect the grounding system regularly to ensure it is in good condition. Tenthly, consult with a qualified electrician if you have any questions or concerns. Understanding the role of grounding is important. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices to operate and clear the fault. Without proper grounding, fault current could flow through unintended paths, such as through a person touching a metal enclosure, resulting in electric shock. Grounding also helps to stabilize the voltage to ground, reducing the risk of voltage surges and other electrical disturbances. In the context of the two 200 amps panels, connecting both to a single grounding electrode system is acceptable because the grounding system is designed to handle the maximum fault current that could occur in the system. The 400 amp service entrance conductors determine the size of the grounding electrode conductor, which is sized to safely carry the maximum fault current. The grounding system does not need to be sized based on the individual panel sizes, but rather on the overall service size. The connection between the two panels and the single ground rod is typically made by running a continuous grounding electrode conductor from one panel to the other, and then to the ground rod. This ensures that both panels are effectively grounded. Alternatively, separate grounding electrode conductors can be run from each panel to a common grounding point, such as a grounding busbar, which is then connected to the ground rod. This method can provide a more robust grounding system, as it provides redundant grounding paths. However, it is important to ensure that the grounding busbar is properly sized and installed to handle the maximum fault current. In addition to the grounding electrode system, it is also important to ensure that the neutral conductor is properly grounded at the service entrance. This is typically done by connecting the neutral conductor to the ground bar in the main service panel. This connection provides a reference point for the electrical system, and it helps to ensure that the voltage to ground is stable. It is important to note that the neutral conductor should only be grounded at the service entrance. Grounding the neutral conductor at multiple points can create circulating currents, which can cause problems with the electrical system. These circulating currents can also create a shock hazard. When installing electrical systems, it is important to follow all applicable codes and regulations. These codes are designed to ensure the safety of people and property, and they should be strictly adhered to. The National Electrical Code, or NEC, is the primary code used in the United States. The NEC is updated every 3 years, and it contains detailed requirements for the installation of electrical systems. It is important to stay up to date on the latest version of the NEC, as the requirements can change over time. In addition to the NEC, there may be local codes and regulations that also apply. These local codes may be more stringent than the NEC, and they should be followed in addition to the NEC requirements. When working on electrical systems, it is important to take safety precautions. The electrical work can be dangerous, and it should only be performed by qualified and experienced individuals. Always disconnect the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. A qualified electrician has the training and experience necessary to perform the work safely and correctly. They can also ensure that the electrical system is installed in accordance with all applicable codes and regulations. In summary, when wiring a home with two 200 amps panels served by a single 400 amps meter base, only one ground rod and grounding wire is required. Both ground wires from the panels should be bonded to the single ground rod. This configuration meets electrical code requirements for grounding, promotes safety, and ensures the proper functioning of the electrical system. Always refer to the latest edition of the National Electrical Code and local regulations for specific requirements, and consult with a qualified electrician if you have any questions or concerns. Proper grounding is essential for electrical safety and system performance. The 200 amps panels each need a 4-wire connection. 4 wires are 2 hots, a neutral, and a ground. The hots provide the 240-volt split-phase power. The neutral is the return path for 120-volt circuits. The ground is the safety wire. The ground connects to the ground rod. The ground also connects to the metal chassis of the panel. The ground provides a low impedance path for fault current. If a fault occurs, the fault current will flow through the ground wire back to the source. This will cause the circuit breaker to trip, energizing the circuit. Without a proper ground, a fault could energize the chassis of the appliance. This could create a shock hazard. The ground rod should be driven into the earth until at least 8 feet is in contact with the soil. The ground rod should be located away from any underground utilities. The ground wire should be connected to the ground rod with a listed connector. The ground wire should be sized according to the National Electrical Code. The neutral wire is grounded at the service entrance. This is the point where the power enters the building. The neutral wire is connected to the ground wire at the service entrance. This connection provides a path for fault current to flow back to the source. The neutral wire should not be grounded at any other point in the system. Grounding the neutral at multiple points can create circulating currents. These circulating currents can cause nuisance tripping of circuit breakers. They can also create a shock hazard. The electrical system should be inspected regularly to ensure that it is in good condition. The inspection should include checking the grounding system. The ground rod should be checked to make sure that it is still driven into the earth. The ground wire should be checked to make sure that it is still connected to the ground rod. The connections should be checked to make sure that they are tight and corrosion-free. If any problems are found, they should be corrected immediately. Maintaining a safe and reliable electrical system requires attention to detail and adherence to established codes and practices.